Hello and welcome everyone. Thank you for joining us today. My name is Steve Meek. I'm the Regional Sales Manager for the Midwest region of the United States. I joined the WENZEL team back in January of 2019, and as of May this year, I took on responsibility of managing aftermarket service and calibration sales as well. Today I'm joined by my colleague, Jonah DeLongchamp. Jonah?
And again, welcome everyone, and thank you for joining us today. My name is Jonah DeLongchamp, and I joined the WENZEL America team as an application engineer back in August of 2009 until January of this year, where I took over as my new role as product specialist for portable metrology for the NAFTA region.
Thanks, Jonah. So today we'll be talking about how to measure more parts faster featuring the WENZEL LH series CMM. Our machine today will be equipped with the Revo probe head and Quartus software. We have some time designated for a Q&A session toward the end of this presentation. There is a chat box to submit questions to on the right side of your screen. So if you have any questions or comments about anything you've seen today, please send them in, and we'd love to hear from you.
So, Steve, can you discuss with us this LH series frame, and what do you like about it?
Yeah, Jonah, for sure. So today we're working with the LH 10-16-8 CMM. That's in XYZ format. So a measuring envelope today of 1 meter in X, 1600 millimeters in Y, and 800 millimeters in Z. The LH is our flagship CMM. It's hand built at our state-of-the-art facility in Wiestel, Germany. And this is a bridge style machine. It's available in a variety of sizes, ranging from the smaller 6, 7, 5 size all the way up to 20, 40, 15, making it a great option for smaller handheld type parts or even medium to large parts like the engine block we'll be showing you just a bit today. As you may have heard us say before, with premium accuracy now being standard at WENZEL, we offer the LH series frame in 3 different accuracy options with micron and even sub-micron accuracies available into the 10-8 size range. But you asked one of my favorite things about this. Personally, I really like the LH for its versatility. We can configure this, the LH series, to run any of the Renishaw probing systems, including the 5-axis PH20 for your high volume touch trigger applications, or the 5-axis Revo for your high volume, high accuracy tactile scanning applications like we'll see today. Should you choose to build your measuring arsenal even further, you could also run any of the Revo multi-sensor add-ons, whether it be vision, fringe, or surface finish probing. You could run WENZEL's entire line of optical sensor technology, or even add a rotary table to the mix. So although we're still talking about a traditional bridge style CMM, this is far from your typical run-of-the-mill machine. And a quick fun fact about WENZEL, we are the only CMM manufacturer who owns and operates their own granite facility. As you can see on the right side of the screen, we have a couple pictures of the granite. This is important to you for 2 reasons. First, it allows us to build our machines entirely from granite, from the same granite source, ensuring the highest quality from the foundation up on a frame that's truly built and designed to last. All of our frames feature a true one-piece granite table, including the entire Y-axis beam, with our bridge and our Z-quills also being made of granite, except those are core drilled, allowing us to keep the machine speeds up and overall weight down. This structure allows us to maintain the tightest overall system accuracy and a universal thermal expansion throughout the entire frame of the machine. And the second reason this is important, it allows for maximum flexibility in machine sizing. Many of our customers really enjoy this because we're able to add additional length to the Y-axis of their machines, providing custom, larger measuring envelopes without adding much cost.
Yeah, thank you for that, Steve. And so we'll move on, and we'll take us through, please, the probing technology that we'll be looking at today.
Yeah, sure. Let's get down to it. So with our LH frame, the probing technology we're going to hang off of this today will be the 5-axis Revo probe head by Renishaw. If you're not yet familiar with Revo, this is a game changer. The Revo is a highly accurate, high-speed tactile scanning probe. It's specifically designed to eliminate inspection bottlenecks by maximizing your measuring speeds and machine throughput. Unlike traditional 3-axis scanning probes, where you're limited to 7.5 degrees of probe indexing The Revo has infinite indexing and infinite positioning capabilities. This unique head motion technology allows for many measurements to be taken using only the Revo probe head instead of using the machine mechanical structure, which greatly improves system repeatability. This also allows programmers to access normally difficult part features at very quick speeds, up to 500 millimeters per second, and capturing 4,000 data points per second, truly putting the Revo in a class of its own. Again, this sounds great and all, but what does it really mean to you? It means three things. It means faster programming times. It means faster inspection cycle times and increased machine throughput. And it means faster calibration time. So no more spending valuable minutes and even hours calibrating your probe rack. All of this equates to more parts faster. That's the idea today. But now that we've talked about the hardware, let's get into the software side. What we'll be looking at shortly is Wenzel's proprietary software, Quartus. As Jordan will show you over the next 10 to 15 minutes, this is a Windows-based, object-oriented software, provides a very powerful yet fluent user-friendly interface. Quartus offers great connectivity with full CAD import and export capability, offers high-level GD&T programming and world-class reporting and SBC functionality already built into it. Being a novice programmer myself, two things that I really like about Quartus are the self-help menus and the offline programming ability. With extremely detailed step-by-step direction readily available at the touch of a button from virtually anywhere on the interface, and the ability to work, or in some cases learn offline away from the machine, Quartus makes it very easy to self-serve and learn quickly, making it an excellent platform for programmers really of any experience level. But with that said, let's dive into it. Jonah, could you get us started?
Yeah, absolutely, Steve.
Thanks.
So here I'm gonna show you people Wenzel Quartus and just a little bit about the software and the architecture layout. It's all built on the MS Fluent interface. So if you ever use an Office product, it kind of looks and feels that way. And the fact that up here on the top, as I navigate through these tabs, it exposes the different ribbons. So here at the machine tab, the ribbon is only dealing with things at the machine level, things like your probe systems, your calibration artifacts, your probe racks, etc. The measure ribbon, this is one of the popular ones because here in one ribbon, you can measure elements, you can construct elements, and you can align to elements, all done in one ribbon. Then the last ribbon I like to discuss real briefly is the features. So here in the features is exactly that, your tolerancing, what you see on the blueprint. And in here you would see all tolerances, whether they be some simplistic standard tolerancing, distances, sizes, etc., as well as all the GD&T functionality in here. So to carry on with the architecture and layout, here in the middle window, here we have our work window, and it's just a matter of me toggling between these different work windows to expose different views. So here the report window, the database work window, and the graphics work window. The other work window I do have open is the program for this object that you see on the screen here, this engine block here. And the program work window for this complex block isn't thousands of lines long, it's only 100 and some change lines long. The last piece of the puzzle is off to the far right, where the status, what currently is happening with Quartus. Am I connected to the machine? What work piece am I working on? What measurement am I working on? What probe do I have on, etc.? What alignment am I in? So that being said, I'm going to go ahead and execute this program, and so we can discuss on how the program runs and what the Revo is doing in conjunction with these elements it's measuring. So here the probe is locked, the machine is moving, the Y carriage probe rotates, and now it's doing all 5-axis type scanning. So here it can either keep the probe head locked and move the machine, or keep the machine locked and move the probe head. So here, as you notice on the screen, it's just doing a series of circular scans, very quick. Those aren't very big holes, but very fast scans, roughly around 400 points. And the point data you can choose to set as you set up your measurement. So here we're going to go into the 4 cylinders for this engine block here. And this is a helical type scan where it's using all now 5 axes, the X, Y, Z, of the machine and the A and B angle of the Revo probe head to accomplish this. So as it completes here these 4 bores, this is a type of path you can create with the Revo and with Quartus, but you'll see the other types of paths as we go, as I demonstrate how did I get to scanning these bores. So what you see here is one of the tools that you can apply to the Revo, which is the RSP2, which is that full functioning 5-axis high-speed scanning tool. With that being said, it's one calibration, and one calibration complete, then I can move the tool anywhere inside of its spatial volume and measure. So here it comes to the side where the oil filter gets placed on the engine block. It's a planar feature, but moving in a circular type pattern. Now, not only can it scan, but it can also take touch trigger points. So what it's doing here, it's moving the carriage and flicking the head at a head motion to do head touches for individual point measurements. So the A and B angle that you see of the probe head, your B is your clocking around from 0 to 360 degrees, and your A is currently sitting at 0, 0 currently right now, but it can go all the way up to 120 degrees up in A. So if you need to get up underneath a part, the Revo is a great tool to do that. So there at the end there, from the last few lines of code, it was creating all those features or those tolerances, and now it's generating a multiple page report, and it's a blending of reporting tools. You'll see when it's completed here, I'll have some graphical reports, some formula reports, and some numerical data report. And here's what I was mentioning about these different reports. So on page 1, it's landscape. This is a template that I have predefined. But on the left-hand image is what I refer to as the graphical report, and the fact that I can see the CAD model. I see some leader lines and some information contained inside the boxes. So it's very visual oriented here. On the right-hand side of page 1 is a different type of graphical report where you see the color differentiation. That's the heat map or AKA format reporting. Okay. So on page 2, you'll see 2 images again, a left and a right, one at the front of the engine, one at the back of the engine, and some of those tags explaining the diameter and the deviation. And one final graphical report here, kind of an overall view showing the true positions. And then moving on to our table type report, pretty standard layout here for numerical data, where in the fact I see a nominal value, an ISO class if there happens to be one, an upper tolerance, a lower tolerance, the actual reported value, the deviation, a percentage, and then a graphical bar for a visual indicator. Is it in or out? Is it green, yellow, or red? So,
Jonah, those reports look great. Thank you for walking us through that program. As you guys can see, the Revo makes pretty quick work of the engine block, completing the entire program in just a couple short minutes. Jonah, one thing that our customers really like about Quartus is the ease of programming. Would you be able to maybe show us how you create and maybe edit some of those features on that program?
Sure thing. So I'm going to take as an example here. I'm just going to zoom into this this oil filter here area of this part, and I go to the measure ribbon, and then I select what I'd like to measure. I'm just going to go for a simplistic 2-dimensional circle here. Since I have the CAD model, when I select on the model here, a left mouse button click with my mouse, a control, and another left mouse button click to join 2 entities together to become one. Once I'm happy with my selections, left mouse button, I can then simply right mouse button click to accept that. And from here, then I can go ahead and set up the rest of the ribbon. So from here, the nominal data, that all comes from the CAD. Here, my reference element, I can select nominal values because I have that CAD model. I can set up my calculation. So at the time of measurement, when I collect the data, how would I like to calculate? And then here, because I'm scanning, I'm going to also set up outliers and filtering and adaptive or Gaussian filters there. So all things there at this geometry level of the ribbon. So once I'm happy there, I move on to the distribution, and from here I can select how the path is to be done. Well, for a 2-dimensional circle, that's really all you can do is a circular path. However, if it's a cylindrical feature, you can do a series of circles, a series of lines, or as you saw earlier, a spiral or helical type path. What controls do I have here? Well, I have the depth of measurement here, so it's just a matter of me using the up and down arrows to adjust the depth. And then the sector, how much of this circle would I like to measure? I'm going to start at 0 and go all the way around 360. And then here I also have the desired number of points, either number of points that I want to come back into Quartus for calculation, or a distance between each point. So as I move down, the more points I can collect. And the other thing I have in here too as well is the safety plane. So this is going to keep the probe away from that object at this value, 50 millimeters. The next thing is, because it's the Revo, I do have the ability to create head orientations here. And the current one that I have on here is off, so it's going to try and use the probe sitting exactly where it's at to try and scan this circular object. Not going to work out. However, I can select here critical angles, fixed angles, or focal points. All do different functions, but I'll just show as an example critical angles. And here I give it a value, a max value. So 15 degrees I think would work good for this application. And if everything's good, I just simply hit the start button. And here you see the probe automatically articulate to that nominal geometry, make that circular scan path, and report back all those points. And now I've got a calculated circle. So that's how you create scan paths or measurements inside Quartus. But let's say I needed to make a change in the program. So if I go back up to one of these bores, one of these cylindrical cylinders that I did in the front of the part, with my left mouse button, I simply double click inside the program on that line of code. It brings me right into the ribbon like I showed before, where I can set up, different things here. Maybe I just say I want to create some more points. So here I'll just drop down my number. I'll go half value here, and now you'll see I got quite a bit more points coming through. So it's very easy to get into the program and edit that program. Once we edit, it's just a matter of me saying accept that line of code, that change. Now the next time it'll run, it'll use those parameters. So when I'm done editing the code, I just flip the switch back to stop mode, and I can carry on. So the other thing that I like to show is this diameter that I just completed measured. It was measured with least squares. Okay, so that's interesting. So it gives me the calculated result, as you notice here. 20.5, and it measured 20.499. So if I go to features and I just look at one feature to show as an example size, and in the size here, it's pointing here to the last thing that I've done, which is this ID of this element. The feature ID is what you would typically see on your blueprint, like a balloon number, etc. But here, I can actually recalculate this element at the feature level. So maybe I wanted to know the Chebyshev algorithm applied at the time of feature. It's just a matter of me selecting that. I don't have to remeasure it. I don't have to reconstruct that element. It's just a matter of me selecting here only at the feature level how I'd like to calculate. So here the actual now changes, as you see, it's 20.501 instead of 20.499, so it did do the calculation. The nominal data that happened to come from CAD, but here it's open for me to type in a nominal. Sometimes that's not always the case. The nominal CAD is showing one thing, but the blueprint shows a different value. Okay, 20 minus nothing plus 0.5, nominal 20.25. The upper and lower tolerance, just to explain real quick, if it's a split tolerance, which most of them are, if I type in the first tolerance, the second one gets automatically split. And the other neat thing with the size feature is the ISO. So if I look here on my blueprint and I see that it's got an H7 class to it, I simply key it in. And as I navigate to the next window, you can see that it automatically applied that tolerance for H7 for this diameter circle. So once I complete here, I simply say evaluate. And the other neat thing with these ribbons is that it can be turned to repeat mode. So the repeat mode turned on, I just simply go through and select my next thing I'd like to evaluate. Everything stays the same until I make a change on it. So it's very easy to create your features one right after another with the repeat. Not only do you see the repeat ribbon here on the features, but you also see it for constructing elements and measuring elements. So once I create these features and to put all these features in everything that I've done so far in this workpiece, to create a report. So if I go here to the Quartus, the main Quartus dropdown, and create something new, one of the new things I can create is obviously the report. So here it allows me to select from a template, and you'll notice here in my Windows Explorer here, I have lots of different templates, pre-made templates, so you can have as many templates as the customer desires. You can have a green and yellow one for John Deere, blue and white one for Ford, etc. But here I'll just select one that I've already pre-made. A little bit different layout than what you saw before. The header's a little bit different, but all that stuff is very customizable as far as reporting goes. So it's just a matter of me selecting left mouse button, double clicking inside here. And here now I can see all the features that come through. I just pick a handful of them here. And I want to add those from my list to what I want to see inside of this graphical report. And I say OK. So once this happens, it kicks me right over into my graphics work window and the fact that I can rotate, zoom, and pan left, right, up, and down. So once I get an image that I like, I simply say adopt the view, let that view be adopted. And here comes those three things that I've moved from my available to what I want to see on my report. Yes, they're already lined up to the top, but if I don't like that, I can simply just grab these and move them around. Once this is now docked, the report stays locked and docked. The CAD model won't change position. The tags won't change position. It's just the information inside from run to run will change the actual values. So that's the how I create a graphical report or the format report. And the second one type of report is the table report. So here again, I'll only select just a couple of them here. And you can also pre-sort these two. Everything's pre-sortable. So now I'm working from diameter, let's say 1 to 5, and I add those in. You can also app sort here too as well if you choose. But to me, it's a lot easier to pre-sort, add them to my selection, then say okay, so that everything's lined up and in order. So it really doesn't matter when you put in the measurement, when you put in the feature in the program, if you're programming, because at the end it's all stored in a database and you just pull out what you want and put it in the report in order. And now from there, what can I do with this report? Well, I can go up here and I can obviously print the report to a hard copy printer, or I can save. And I just want to show real quick what type of reports. It's the common ones, what most people are looking for. Quartus report for those people that work with Quartus. Outside of Quartus, we can look at PDF type files, the text files, and the CSV files, all different types of reporting output formats.
So Jordan, now that you're showing us the files, this is kind of a perfect segue into another very cool feature about Quartus and what our customers like is they don't have to use the third-party SPC. It's built in. Could you show us a little bit about what that looks like here when you wrap up the reporting side?
Yes, that is true, Steve. So here I have a work window that's called statistics. So let me open that up. Might take a minute for it to open up because it's trying to compile all the data here. Okay, so at the very top here is all of my different features that I have. So if I use my slide bar here, let me just pick a nice green one here to then load diameter 15. And down here at the bottom here, I have the views. So I have an overall view, kind of a mixed match of different graphs. I have the data page, kind of let me know everything that's going on with this feature. And then of course I have the trend diagram, which you saw a little bit earlier, and the histogram diagram. So all those things are put together in the statistical work window. Now the statistical work window can also work with the ribbon up top and the fact that you have filters. And the filters are nice because this same dialog that you see in front of you is not just for statistics, but it can be for reporting, the reporting tool that I just showed you. Then what I can do here is I can say, you know what, I only want to see maybe diameter 1 and 5. Those are really important to me. And also I want to see just those two, but I want to see over a period of time. So it's a matter of me turning on these filters, and maybe I only want to see from measurement record 5 to 12. Okay, so when I say okay to this, now the filters have been applied, and it restricts all the data that I didn't want and only shows me the two things that I selected and just those measurement dates or the measurement record ID number. And again, this can be all done with the reporting tool as well. So you can create a customized report looking at diameter 1 for the past 6 months, or a mismatch of different features that you want to know something about. So there's your brief introduction into statistics. But all that stuff is built in with WM Quartus.
Okay, well, thank you, Jonah. That looked very nice. We appreciate you walking us through that. kind of recap on today. So we've talked about the reliability and flexibility of the WENZEL LH. We talked about reducing cost and increasing productivity and throughput with the 5-axis Revo. And we've learned how quick and easy it really can be to program with WM Quartus. I mentioned earlier that we'd leave some time for Q&A toward the end of the presentation. So at this time, I'd like to dive into kind of the questions that we've seen. We have a couple submitted so far. So I'd like to take a look at some of those from the audience. Jonah, first question looks like it's for you here. Does Quartus have any ISO or ASME standards built in?
It does. Let me close this and get back into Quartus so I can show you. Minimize and get back into Quartus. Yeah, so back up to our feature ribbon, okay, and back up to the graphics and all the statistics. So we just discussed about the ribbon itself, but at the very beginning is the settings. And in the settings here, you'll notice at the very top is the ISO and the ASME, okay? So it's just a matter of selecting what format I want to be in. Depending on what it is, you also have the settings for those. So for an example here, the general ISO or DIN tolerances here, we have the machined, we have the sands, the casting stuff, the synthetic preforms, etc. All that stuff can be selected in here. You just make a selection on what you're doing, whether it be fine, medium, or rough for machine reshape surfaces.
All right. Thank you, Jonah, and thank you for the question. Another question, Jonah. Looks like we covered the export file types, but from the crowd, what file types can Quartus import?
Oh, good question. So here in the Quartus, the main dropdown where I go to create that new report, we also have the import functionality and the export functionality. So if we just quickly look at the import, the more common one is the CAD models. Yeah, so if we just take a look at what type of CAD files we can import here, I just select here the add button. And this now allows me to show all models here. But if I open this up, you can see now there is a list of all the different supported CAD models that can be imported into this environment. Of course, the common ones being the STEP and the IGES, but you can directly do a CAT part or a SLD PRT for a SolidWorks CAD model.
Okay.
Some of the other importing things that you've noticed in not just CAD model, but it can be importing what we call VDA data. And those are elements that were collected from a previous run for reverse engineering purposes. You can measure all these elements and export those out. When you re-import them in, the actuals become nominals, and you can compare to what you measured to what you made. So that's some of the import functionality. The export functionality is kind of the same thing as where I just discussed about the elements. That seems to be the most popular one, is exporting the elements out as reverse engineering. So you have a copy, a record of those.
Okay. Thank you, Jonah. Very quickly, we're going to tackle one more question here. Jonah, could you show us a bit about what the self-help menus look like, just very quickly?
Yeah, sure. So it's all based on where your cursor is sitting at in the interface. So if I put my cursor over, well, let's say size again as my example here, and just hit F1 on my keyboard, it navigates and brings me right to what my cursor was sitting over. There it is, the size. Here's the elements that you can apply for size. What these different settings mean that I just talked about, the ISO and the ASME. And what you see beyond that, what length, what width, or things like that, but it's all done right here in the help file. Mm-hmm.
Thank you, Jonah. And like I said before, as a novice programmer, this is very helpful. You can do this from anywhere in the software, over any icon.
Absolutely.
But we're creeping up on our time limit here today, so I just wanted to say thank you again to everyone for spending your time with us this afternoon. This means a lot to us that you've shared your afternoon with us. We have some questions that we've not been able to get to yet, but we do have your contact info, and we will follow up with you in the next couple of days. Jonah, if you could click on the slide with our contact info here.
Absolutely.
I'll leave this out for a couple moments here. There is a link to where you can find more info at wenzelamerica.com, and also Jonah and I's contact info should you want to reach out before we follow up with you here in a couple days. But that'll do it for today. Thank you again for joining us for how to measure more parts faster, featuring the WENZEL LH and Revo and Quartus. Everybody have a great rest of the afternoon, evening. We'll talk to you soon.
Thank you, Steve, and thank you, everyone.